if you're working out one of these problems and it's happening in a basic solution, you do absolutely everything the same up until the very end. So here is our previous example. We did it in an acidic solution. We got to this point, and so that's how you would work it out, even if it were in a basic solution. And then you just add in some final steps. So here's our answer for an acidic solution. So we're going to make that basic. And what we're going to do is, now what it means to be a basic solution is that you have an abundance of hydroxide ions, not an abundance of hydrogen ions. And so what we're going to do to make this a basic solution is we're going to add in hydroxides. How many hydroxides are we going to add in? We're going to add in an equal amount to the number of hydrogen ions. So we're going to add 2 hydroxide ions to this side. But we're also going to add 2 hydroxides to the product side. Now, we haven't talked about this yet in class, but it makes a lot of sense. Actually, we did kind of with double replacement reactions, but when you take a hydrogen ion and you add a hydroxide ion to it, they are going to go together and they are going to produce water. And so if I do that twice, if I do 2 hydrogen ions and 2 hydroxide ions, those are going to come together and make 2 water molecules. Now there's nothing for these hydroxides to combine with, so you're just going to be left with hydroxides, and then those hydroxides that didn't react with hydrogen ions, that is what's going to make it basic. So then everything's going to be the same. We got 2 waters from the combination of the hydrogen ions and the hydroxide. You have the 2 iodate ions. You have 5 sulfite ions. They produce the elemental iodine, a water, 5 sulfates, and our 2 hydroxide ions. And just like on the previous type of problem, we can reduce anything that's on both sides. And so since you have 2 waters there and 1 water there, right, that means just 1 water jumped the arrow, it didn't do any chemistry. So we can get rid of 1 water on each side. And so we get rid of that water, and we can get rid of one of these waters. So just no coefficient, implied 1, and get rid of that superfluous plus sign, and there we go. It looks like a good answer. You can verify that it is a correct answer, or against all probability it's a correct answer. Again, the same way we did with the acidic solution. It is charge balanced and our atoms balanced. So right now this side of the equation would have, let's see, you got 0 and -2 and 5 -2s, so that's 7 -2, or so. All right, so -12 on this side, so 5 -2s, that's -10, -1 for -12. This side you got neutral iodine, you got 5 -2s and 2 -1, so that's also -12. So charge is the same on both sides. And let's see, how about atoms? You got 2 hydrogens, 2 hydrogens, 2 iodines, 2 iodines, 5 sulfurs, 5 sulfurs, and then you got 5 sets of 4, so that's 20, 1, 2, so 22 oxygens. 5 sets of 3, that's 15, 2 sets of 3, that's 6. 15, 6 makes 21, and then 1 from the water, that's 22. So 22 oxygens on each side. So I'm going to say that this is correct.